Hi, hello friends, welcome to our channel Study of Mathematics. Next, we will go to exercise 3b. In exercise 3b, section 1, in section first 1, first problem. In first problem, we have 8 sub problems. In that first sub problem is first matrix -1, 4, 2, second matrix 5, 1, 3. But in first problem, the condition is find the following products wherever possible. We have to find the product of the given two matrices where that product is possible or not. ఇచ్చిన టూ మ్యాట్రిసెస్ యొక్క ప్రోడక్ట్ పాసిబుల్ అవుతుందా లేదా అనేది చెక్ చేయాలి. ఒకవేళ పాసిబుల్ అయితే ప్రోడక్ట్ ఫైనల్ వాల్యూని ఫైండ్ అవుట్ చేయాలన్నమాట. నెక్స్ట్ in the first problem solution. First given matrix, write down -1, 4, 2. Second matrix is 5, 1, 3. In this product, the first matrix order is, we have 1 row and 3 columns, that is 1 by 3 is order. In second matrix, the order is 3 by 1. We have 3 rows and 1 column. The order is 3 by 3. If we know when the product is possible, if let A is one matrix and B is other matrix, the AB product is possible when the order of A matrix is m by n and B matrix order is n by q. Then that means the number of columns of a first matrix and the number of rows of a second matrix are equal, then that two matrices are productable. Then the producted matrix order is m by q. This is our known formula or known rule. In that way, by using this, the first matrix order is 1 by 3, second matrix order is 3 by 1, and the first matrix number of columns is 3, the number of rows of a second matrix are equal, then the given first subproblem product is possible. That is equal to, this row is multiplied with this column, -1 into 5, -5 plus 4 into 1, 4 plus 3 into 2, 6. That is equal to 10, 10 minus 5, 5. This matrix order 1 by 1. By this formula, we have also 1 by 1 matrix. The remaining answer formula also 1 by 1. In that second sub problem, the given matrix is 2, 1, 4, 6, -2, 3. And the second matrix is 1, 2, 1. And then taking solution, first write down the given matrices 2, 1, 4, 6, -2, 3. Second matrix 1, 2, 1. The first matrix order is 2 by 3. Second matrix order is 3 by 1. The number of columns of a first matrix, the number of rows of a second matrix are equal, then this is also productable. That is 2 into 1, 2 plus 2 plus 4, 6 minus 4 plus 3. Then the order is 2 by 1. That equal to 8, 5. This is the solution of second subproblem. In that third problem, the given matrices 3, -2, 1, 6. Second matrix is 4, -1, 2, 5. Then taking solution, write down the given matrices 3, -2, 1, 6. And the second matrix 4, -1, 2, 5. The orders are 2 by 2 and 2 by 2. then product is possible. 12 minus 4 minus 3 minus 10, 4 plus 12 minus 1 plus 30. Order is also 2 by 2. Then that is equal to 12 minus 4, 8 minus 13, 16, 29. This is the producted matrix of third subproblem. We will go to fourth subproblem. Fourth one, the matrices are 2, 2, 1, 1, 0, 2, 2, 1, 2. Second, minus 2, minus 3, 4, 2, 2, minus 3, 1, 2, minus 2. This is our given matrices. Then find out the solution. The given matrices 2, 2, 1, 1, 0, 2, 2, 1, 2. And the second matrix minus 2, minus 3, 4, 2, 2, minus 3, 1, 2, minus 2. The order is 3 by 3 and 3 by 3. Number of rows, number of columns. Number of columns, number of rows are equal. Then that is equal to product is possible. That is minus 4 plus 4 plus 1. This row, this column. Minus 6 plus 4 plus 2. 8 minus 6 minus 2. This row and this column. Minus 2 plus 0 plus 2. Minus 3 plus 0 plus 4. 4 minus 0 minus 4. Minus 4 plus 2 plus 2. Minus 6 plus 2 plus 4. 8 minus 3 minus 4. That is equal to minus 4 plus 4 get cancelled, then 1. Minus 6 plus 6, 0. 8 minus 8, 0. Plus 2 minus 2 get cancelled, and 0. Minus 3 plus 4, 1. 4 minus 4, 0. Minus 4 plus 4, 0. Minus 6 plus 6, 0. 8 minus 3 minus 4. Minus 7. 8 minus 7, 1. That is equal to I, identity matrix of order 3 by 3. In that fifth problem. In this fifth problem, the given matrices are 3, 4, 9, 0, minus 1, 5, 2, 6, 12. First matrix. The second matrix is 13, minus 2, 0, 0, 4, 1. This is the given matrices. And then solution is, first write down the given matrices. 3, 4, 9, 0, minus 1, 5, 2, 6, 12. Second matrix is 13, minus 2, 0, 0, 4, 1. And the order is, this is 3 by 3. And the second matrix order is 2 by 3. In this first matrix, the number of columns are 3, and second matrix, the number of rows are 2. These two values are not equal. Then this product also is also not possible. Not possible. Product is not possible because the number of columns of a first matrix and the number of rows of a second matrix are not equal, then the product is not possible. We will go to next, sixth problem. Sixth problem, 1 minus 2, 1. Second, 2, 1, 4. 6 minus 2, 3. This is a given matrices, and write down first column matrix minus 1 minus 2, 1. Second matrix 2, 1, 4. 6 minus 2, 3. In this, the first matrix order is 3 by 1. Second matrix order is 2 by 3. Here also, the number of columns of a first matrix and the number of rows of a second matrix are also not equal. Then the product is also not possible. The above product is not possible. Is not possible. Next we will go to seventh problem. In the seventh problem, the given matrices 1 minus 1 minus 1 1, and the second matrix is 1 1 1 1. This is our given matrices. Then we will go to solution. First write down the given matrices. The order is 2 by 2 and 2 by 2. Then the number of columns of a first matrix, the number of rows of a second matrix are equal. Then product is possible. That is equal to first this row, this column. 1 into 1, 1 minus 1. 1 minus 1 minus 1 plus 1 minus 1 plus 1. 1 1 get cancelled, all ones are cancelled. That is equal to 0 0 0 0. This is a null matrix. This is denoted by O of order 2 by 2. Next, final problem in the first problem. Then the eighth problem is the first matrices is 0 C minus B minus C 0 A B minus A 0, and the second matrix is A square AB AC AB B square BC. Next AC BC C square. This is our given matrices, and the solution is, first write down the given matrices 0 C minus B minus C 0 A B minus A 0, and the second matrix is A square AB AC AB B square BC AC BC C square, and the order is first matrix order 3 by 3, second matrix order also 3 by 3. Then the matrix multiplication possible, that is equal to, first we multiply first row with first column in the second problem. Second matrices 0 into A squared 0, C into AB plus AB ABC minus B into AC minus ABC. First row with second column. 0 into AB 0 plus B squared C minus B squared C. First row with third column 0 plus BC square minus BC square. In the similar way, minus A squared C plus 0 plus AC square. Sorry, A squared C. ABC minus ABC plus 0 plus ABC. Next, minus AC square plus 0 plus AC square. Next, BA square minus A square B plus 0. AB square minus AB square plus 0. ABC minus ABC plus 0. Here plus ABC minus ABC get cancelled. See, all terms are cancelled. Here BA square or A square B is equal, then that also cancel. That is equal to, all elements would be 0. Then that is null matrix O of order 3 by 3. This is the first section, first problem, all sub-problems solution. In next video, we will go to some more problems in the same exercise. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.